Hello everyone. Today we are going to solve numericals related with a deadlock. Let's start with the problem. First numerical is a system is having six processes, each requiring 3 units of resource R. What should be the minimum value of R to avoid deadlock? Solution. In order to solve such problem, we have to first compute summation of need, which is represented by summation of xi. Since we are having a 6 process and each process requires the 3 unit, so therefore sum of need of all process will be equal to 18. Number of process is 6, therefore minimum number of resource to avoid deadlock is summation of xi minus n plus 1, that is 18 minus 6 plus 1, that is 12 plus 1, that is 13. So with minimum 13 resources, system assures that there will be no deadlock at all. Let's see another numerical. A system is having ten process, each requiring 2 units of R. Then what should be the minimum value of R to avoid deadlock? Since we know that the minimum number of resource to avoid deadlock is equals to summation of xi minus n plus 1, where summation of xi represents sum of need of all process. Here we are having a total 10 process and each process requires 2 unit, therefore need of all process is 20. Number of process is 10 plus 1, so 20 minus 10 plus 1. So with 11 number of process, system is assured to be a deadlock free. Now we are going to see next type of problem. So the question number 3. A system is having 3 process, P1, P2 and P3. P1 needs 4 units, P2 needs 10 units and P3 needs 5 units of R. So what should be the minimum value of R to avoid deadlock? To solve this problem, again we have to first calculate summation of xi, that is sum of need of all process. In this problem, process P1 needs 4 unit, process P2 needs 10 unit, process P3 needs 5 unit. So total is 19. Number of process is 3. Therefore, minimum number of resources to avoid deadlock is equals to summation of xi minus n plus 1, that is 19 minus 3 plus 1, that is 16 plus 1, that is 17. So with 17 resources, system is always in deadlock free state. Now we are going to see the next question, question number 4. A system with 100 resources and m process, where each process needs 10 units of resource. So what should be the value of m to avoid deadlock? Solution. In worst case, or we can say in case of deadlock, each process holds need minus 1 resources. Since here each process need 10 resources, so the process P1 will hold 9 resources, process P2 will hold 9 resources, process P3 will hold 9 resources. Similarly, process P11 will hold 9 resources and process P12 will hold 1 resources. So with 12 process, there will be a deadlock, but we are required to find value of m such that there will be no deadlock. So m should be 12 minus 1, that is 11. With 11 number of process, system is always assured to be a deadlock free. Now next question, a system with 6 process each requiring 2 units of resource R. What should be the maximum value of to ensure deadlock? Solution. In this problem, we have to ensure deadlock. So first we have to calculate summation of xi, that is need of all the process. Since in this problem we are having a 6 process and each process requires 2 unit, so the sum of need will be 6 into 2, that is 12. N is 6, therefore max number of resources to ensure deadlock is equals to summation of xi minus n, that is 12 minus 6, that is 6. So if the number of resources is 6, then there will be a deadlock. Now we are going to solve one more problem. A system with 20 resources and k process. Each process needs 4 units. Then what should be the value of k to avoid deadlock? Solution. In worst case or in deadlock case, each process holds need minus 1 resources. Here the need of each process is 4 unit, so process P1 will hold 3 resources, P2 will hold 3 resources, P3 will hold 3 resources, P4 will hold 3 resources, P5 will hold 3 resources, P6 will hold 3 resources, P7 will hold 2 resources. So system will be in deadlock if number of process is 7 or more. Therefore, k will be greater than equal to 7.